Hello students, how are you? I hope you will be fine. Dear students, today we will discuss about chemical thermodynamics, and in chemical thermodynamics today's topics are the introduction or some basic terms related to thermodynamics. Okay, so let's start our discussion. First, see, in today's session what will we learn? System and surroundings. After that we'll see the extensive and intensive properties, state function and path function, and at last types of process. Okay, so let's start. First part is system and surroundings. The before system and surrounding, let's introduce the thermodynamics. So what is thermodynamic? The branch of science which deals with the study of different forms of energy and their interconversions is called thermodynamics. It means in a chemical reaction, if heat is produced or heat is absorbed, then that chemical reaction will be studied under thermodynamics, and also the effect of heat on the type of reaction or on the reaction types, it will be studied under thermodynamics. Now we will see the system. The part of the universe which is under observation is called system. It means definitely we will complete the chemical reaction in any container. Okay, for example, beaker, it may be beaker, it may be a china dish, it may be some other containers. So the part of the universe in which that reaction is taking place, that portion is called the system. In case if we are going to titrate, then burette and pipette, this is called the system, and except burette and pipette, the remaining part is called surrounding. So what is system? System, this is the part of universe which is under observation. Okay, and the remaining portion of universe, that is called surrounding. Except system, all the part of surrounding part, it is called surrounding. But here the question is, now if I am going to perform the chemical reaction in chemistry lab, okay, then from where we can exchange the heat, or we have to see the relation between the chemistry lab with outer environment. So here see, if that chemistry lab, in this chemistry lab, if some gases are produced, for example H2S gas is produced, or any gas if it is produced, then this gas can travel from chemistry lab to outer part. Okay, so only this small area is it will be affected by the chemical reaction. Okay, so that small particular area, that is called the surrounding, not the all part of universe. Because if I am performing an experiment, okay, or very simple, not in experiment, very simple, if in our room, if we are heating fire, if we are heating wood, okay, so definitely the room, it will get warm, but only the room will be it will warm now, but the remaining part of your town, your village, your district, your country, the remaining part, it's not affected because of the fire. So here see, what is the effect of that fire? This effect will be only inside the room. Outside room, there will be no effect. So that small room is called surrounding. Okay, all are surroundings, but that small room, that is called surrounding, because that is affected. So here we can say the relation between system and surrounding. So the relation is called, in that relation we have to study. So what is system and surrounding? So very simple. Now if system plus surrounding, if we add these two parts, then the it will form universe. So what is the system? We can say system equal to universe minus surrounding. Or what is surrounding? Universe minus system. But remind this thing, surrounding, it's not the all part of universe. Okay, all parts are actually surrounding, but the portion of surrounding which is affected by the system, we have to study that portion. Okay, So don't confuse about surrounding and about universe. Universe is all we can see, that is a universe. You know, universe is very, very well, but surrounding. Okay, so this is the system and surrounding. Now we'll see the types of system. First is open system, a system which can exchange energy as well as matter with its surrounding is called open system. So example is hot water in open container. See, this is the universe, means surrounding. Okay, in this surrounding I'm taking a beaker. This is a beaker, and in this beaker, if I fill this beaker is a system. Why? Because we are filling water into this beaker, so that beaker is called system. And now we have to see the relation between system and surrounding, means beaker and our environment. Environment means the outside portion of beaker. Okay, so see, in this case, when we fill hot water in open container, so definitely heat, it will go from system to surrounding. Okay, because obviously water temperature of water is more than surrounding. So if hot water is filled in this beaker, then heat will be transferred from system to surrounding. And also the matter means what? Now if you boil this beaker, this water, okay, if we boil this, then definitely water, it will convert into vapors, and the vapors will go in air. So with the time, the volume, mass of the water, it will decrease, or the amount of water, it will decrease. So what is happening here? Water is exchanging, means water vapors, or simply we can say water is growing from system to surrounding, and also heat is going from system to surrounding. So this type of system is called open system. It's a open, where heat and heat means energy, heat and matter both can exchange between system and surrounding, not only from system to surrounding, maybe from surrounding to system. For example, if you fill cold water in beaker and leave this beaker in sunlight, then definitely after some time the water will become warm. Why? Because the heat from surrounding, it is coming into system, so heat is transferring. Okay, so this type of system is called open system. In very simple word, क्या इसमें हम सिंपली क्या डिफाइन करेंगे कि जो हमने सिस्टम लिया हुआ है, उस सिस्टम का और सराउंडिंग के बीच में हीट और मैटर दोनों एक्सचेंज हो सकते हैं. मैटर का मतलब पानी अंदर से बाहर भी जा सकता है और बाहर से अंदर भी आ सकता है, वो हो गया मैटर का एक्सचेंज. और हीट में बीकर से बीकर का जो पानी है वो ठंडा भी हो सकता है, गर्म भी हो सकता है. तो यदि हम ठंडा पानी लेते हैं, उसको धूप में रख देंगे तो ये गर्म हो जाएगा. तो हीट कहाँ से कहाँ आ रही है? सराउंडिंग से सिस्टम में. और यदि हमने इसको हॉट वाटर लिया हुआ है बीकर में और इसको ओपन छोड़ दें, तो कुछ समय बाद वो क्या हो जाएगा? ठंडा हो जाएगा. ठंडा होने का मतलब क्या? हीट कहाँ जा रही है? हीट बीकर से एयर में जा रही है, सराउंडिंग में जा रही है. तो ये हो जाएगा एक्सचेंज ऑफ एनर्जी एंड मैटर. सो दिस इज ओपन सिस्टम. ये यू कैन सी हियर, दिस इज द एक्सचेंज ऑफ matter and this is the exchange of heat. Got it? Next one is the closed system. In closed system, which can exchange only energy but not matter. Okay, that is called closed system. Example, hot water in a steel container covered with lid. For example, now see, before first see the example. Surrounding, this is the surrounding. In the surrounding, what we have taken? A beaker, and in this beaker, if we fill the hot water, okay, in this beaker we are filling hot water, and after filling hot water, cover this beaker with a lid. So if this beaker is covered, then definitely water vapors will be produced. Definitely water vapors will produce, but these water vapors will go up, but they will collide with this lid or this cover, and again it will condense and came into beaker. So here the direction is what? Vapors are converting from liquid to, means water is converting from liquid to gas, gas to liquid. But here the net change is zero. Net change means change in mass. Water is not going from beaker to surrounding. water is present inside the beaker. It is traveling inside the beaker. So water means matter, it's not exchanged. But heat, if this container is of steel or a metal, then definitely if we fill hot water in this steel container, after some time it will get cold. Why? Because heat is exchanging between system to surrounding. Or very simple, another example, take a steel container, fill cold water and cover it, and after covering, leave it open in sunlight. So after some time the water will become warm, okay, but the volume or the mass of water, it will not change. So matter is not exchanging between system and surrounding, but heat is coming from surrounding to system. In this case, system to surrounding, but in open sunlight, surrounding to system. So heat can be exchanged, but matter cannot be exchanged. That is called the closed system. Okay, and last one is the isolated system. What is isolated system? So very simple, isolated system, it means a system which can neither exchange energy or matter with its surrounding is called isolated system. Example, hot water in thermos flask. You know, in thermos flask, if we fill a hot water, then after 1 hour water will remain hot. If we fill cold water, water will remain cold. It means the energy, it is not exchanging, means energy is not going from inside thermos flask. So energy is not going from flask to surrounding, or energy is not coming from surrounding to system. So that is called the isolated system. And one more thing, in this case also matter is not exchanging. So here neither matter nor energy is exchanged between system and surrounding. So this type of system is called isolated system. Okay, see, in this beaker we are filling hot water. So this water is hot, temperature is high, and after filling hot water, cover it. So after 1 hour or 2 hour, neither heat or matter will be exchanged. So these are isolated system. Now we will see extensive properties. The term extensive properties. So extensive properties, it means these are the properties of system whose value depends on the amount of substance present in the system, are called extensive properties. Okay, very simple. Take mass. Mass means take a beaker, and in beaker add 1 gram of substance, any substance, say 1 gram of sodium chloride or 1 gram of chini, whatever you want to take. Okay, so in that beaker the mass is 1 gram. Okay, so mass is what is the value of mass? It's a 1 gram. It depends on number of particles, amount of substance. So mass is 1 gram. Now add some more amount of substance. So the mass depends on substance, amount of substance. If you fill more substance, mass will increase. If you remove substance, mass will decrease. So the value of mass, it depends on amount of substance. Similarly, value of volume, it depends on mass of substance. For example, fill 1 liter of water, the volume is 1 liter. After that, add some more amount of water, volume will increase. Remove some amount of water, volume will decrease. So the volume, it is depending on the amount of water. So such type of properties which are depending on the amount of substances are called extensive properties. And the values are surface area. If amount of substance are more, surface area will be more. Enthalpy, entropy, heat capacity and free energy. We will discuss about these terms, enthalpy, entropy, heat capacity and free energy, in next session. Okay, so for this session, extensive property we have learned. Next one is intensive properties. So these intensive properties are just opposite to extensive properties. Extensive properties, these are depending on mass of substance or amount of substance. But intensive properties, these are not depending amount of substance. Okay, these are independent of amount of substance. For example, temperature. Temperature means, see, very simple. take 1 liter of water in a container and leave it open in air. After 10 minutes, what will be the temperature of 1 liter of water? Okay, note down this temperature. This will be room temperature. After that, add 2 liters of water more in that container. Means earlier we have taken 1 liter. After that, add 2 more liter. So the volume will be 3 liter. Again, leave it for 10 minutes. After that, note down the temperature. Again, the temperature will be room temperature. So what will be the temperature of 1 liter water and what will be the temperature of 3 liters of water? The temperature will become same. So it means temperature, it's not depending on amount of substance. Okay, so that's why temperature is intensive properties. Also pressure is what? Pressure, it depends on mass per unit volume. Oh sorry, it's a force per unit volume. So definitely the pressure, it's not depending the amount of substance, because pressure is unit. So pressure is intensive property. Surface tension means if the surface tension of 1 liter of water is x, definitely surface tension of 10 liter of water will be x. So surface tension will be same. So surface tension, it's not depending on amount of substance. That is intensive property. Okay. After intensive property, we'll see the state function. What are state function? It is a property of the system whose value depends on the state of the system and is independent of the path or manner by which the state is reached. For example, very simple way. What will be the temperature? Initial temperature is 10 degree. After completion of reaction, if the temperature is 20 degree, then the temperature it's depending on initial and final degree, means states of function, not on the path of the function. How we are converting, we are heating, how we are heating by using burner, by using candle, by using gas stove, whatever we have source we are using. Okay, so this temperature is not depending on path. The temperature, it depends on state, initial state and final state. Like that, volume depends on initial state and final state. Okay, so these are the values: pressure, volume, temperature, internal energy, enthalpy, entropy. These are the state function. These value depends on initial state and final state, not on the path. Got it? So these are state function. The change in the value of these properties depends on upon the initial and final state, not on the path of that system. Okay, not on that reaction. So that is the state function. What are path function? So now the values depends on path, not on state. Okay, definition clear. It is a property of the system whose values depends on the path of the system and is independent of the state. Pressure, volume, temperature, internal energy, enthalpy, these are the path function. These are the state function. Okay. So got it? What are path function? Path function, the properties depends on path, not on the state. Okay, for example, work depends on path. Work doesn't depend on initial state and final state, depends on path. So work is path function. Now the last term is types of process. So in types of process, first process is isothermal process. This means those reactions, simply say reaction, those reactions where temperature is constant. What is constant? Temperature is constant. So such type of process, these are called isothermal process. So whenever we are going to perform an experiment, if the temperature is kept constant, then the process is called isothermal process. Okay. Adiabatic process, in such processes heat is constant, heat is not exchanged, heat is not changed. Okay, initial heat and final heat both are same, heat is constant. Isobaric process, in such process pressure is constant. For example, if the initial pressure is 1 atm, final pressure will be 1 atm. Okay, so pressure is not changing. So such type of reactions, these are called isobaric reactions because their pressure is constant, and such process are called isobaric process. Isochoric process where volume is constant. Okay, see, in volume is constant, we can understand this very easy. Volume is constant. Take a beaker. Okay, I'm taking this beaker and let's heat this beaker by covering this beaker via lid. So inside beaker, if we fill water, then definitely after some time water will convert into gas. But what will be the volume of the gas? So see here, this volume is fixed because we have covered this beaker. So volume is not changing, but temperature will change. Initially temperature was T1, but now the temperature will be T2. Pressure of liquid and pressure of gas, definitely pressure of gas will be higher. So temperature and pressure are changing, but here volume is constant. So such type of process, heating of water at constant volume, so such type of process are called isochoric process. Okay, these are isochoric process. In isobaric process where process pressure is constant, so see, again take a beaker, heat this beaker, first fill this beaker by water, and here we are fixing movable piston, freely moving piston. Okay, piston, what is piston? Piston, this is a simply we can say it's a lid which doesn't allow the water to go from system to surrounding. So see, initially the piston, the length of the piston means the length from piston to the bottom of the beaker, this one is this one. If we heat this water, definitely water will get converted into gas. Okay, it will convert into gas. So gas, expansion of gas, because of the expansion of gas the pressure will increase. So if pressure is increasing, then definitely the vapors, they will push this piston upward. So the piston will go, it will lift. So again volume is changing. So here two things are changing. First, temperature is changing, and second, volume is changing. But pressure is not changing. Why? Because earlier the water, it took this place, this volume, but now the piston is moving up, so volume is increasing. If volume is increased, pressure will decrease, so pressure will remain constant. So what is the meaning of this types of processes? Where pressure is constant, isobaric, temperature is constant, isothermal, volume is constant, isochoric. Got it? Next is cyclic process. So in cyclic process, see, cyclic process, we can simply understand the cyclic process by the formation of rain. How rain is forming, or how rain is taking place? Very simple. Water from sea, it is converting into vapors. So what is happening here? So for take example, this is ocean. Okay, in this ocean what is present? First, water is converting into gas, means vapor. Then vapor temperature is lowering in upper surface. Okay, in atmosphere temperature is getting down, so gas, these are condensing. So after condensing the gas will convert into liquid, and liquid will come on the earth. So from earth, or from ocean, we started our reaction. So from ocean into atmosphere, from atmosphere again into ocean. So this is a cyclic process. Cyclic process means now what? From the position, or from the state from where we have started the reaction, so we'll come into that position. For example, if temperature was 10 degree, so after heating reaction, what will we do? 10 degree, heat this substance, temperature is 20 degree, cool this substance, temperature is 10 degree. So from 10 degree we started, and we came into 10 degree. So in path, temperature is changed, but at last the temperature is same. So such type of process where from the point we have started reaction, in that point we'll reach finally in that point. So such type of process are called cyclic process. Okay, it's a cyclic process. See, if A is converting into B, again B is converting into A. This is a cyclic process. Complete circle it is forming. Next one is reversible process. So what is the meaning of reversible process? Reversible means if take an example of water. If we freeze this water, okay, if liquid water is in liquid form, liquid state, so keep this water into fridge, okay, after some time it will convert into ice. So physical state is changed from liquid, it is changing into ice. Again, if we heat that ice will convert into water. So this is a cyclic process, but here the conversion of liquid into ice, this is a reversible process because we can convert ice into water. So the type of process in which the reactants are converting into product, but if we change the situations, if we change temperature, pressure and volume, again we can convert the product into liquid. So this is a reversible reaction in both direction, forward to backward, backward to forward. So such type of process are called reversible process. And last type reaction, this is irreversible process. See, reversible processes, these are represented by double arrow. Okay, means this is a forward reaction one side, again backward reaction. In this arrow we can go in any direction. If we go this side, again we can go back side. So this is a reversible reaction. Okay, and reversible reaction, very simply we can identify these reactions. Either this double arrow will be there or this single arrow will be there. So if these arrows are present between reactants and products, the reaction is reversible process. And irreversible process, these are the reactions or these are the processes which can be carried out only in one direction. Okay, for example, burning of paper, it's a chemical change, but we can convert that ash into paper again. So that is a unidirectional reaction, one directional reaction, one side reaction. So this is irreversible process. So what we can do, we can convert reactant into product, but we can't convert that product into reactant. So such type of processes are called irreversible processes. Got it? So that's all for today's session. Okay, these are the basic terms which will be used in next discussion. Got it? So that's all for today's session. Thank you very much. If you have doubt, you can contact me. Thank you.